first 5 links in the chain of life are nature's raw materials, the sun's energy, the chlorophyll in the plant, topsoil, and the organization of the living community. But the chain is not yet complete. Our life depends on the topsoil, but topsoil cannot support life without water. And water itself depends on one more link in our chain, the forest, which store and regulate its flow. This water comes chiefly from the ocean, where it is evaporated and then carried inland by air currents. But these air currents do not distribute this life-giving moisture evenly. For example, in this country, there are many mountain ranges, and the moisture-laden air drifting in from the sea is forced upward when it strikes the mountains. This cools the air, condensing the moisture first into clouds, and then on further cooling, into rain or snow. Thus the air is robbed of its moisture, and there is little left to supply rain in the country beyond. So life in this dry country must depend on water distributed by nature's arteries from the mountain areas. Fortunately, the forests, which cover most mountain slopes, are nature's best collectors of water. Through the ages, the trees add their leaves and trunks to the forest floor, building it into a vast sponge of humus. A single square foot of this humus will absorb nearly 2 gallons of water. A single square mile of this forest can absorb over 50 million gallons of water after one heavy rain or melting snow. Here on the right, we see how forest cover slows the melting of the snow, allowing it time to sink into the humus. On the burned-over slope at the left, the snow melted quickly and was wasted in a runoff flood. On this bare and unprotected ground, the rain washes the finer particles of soil into the crevices between the larger ones, making the surface nearly waterproof, so that much of the water runs off and is lost. But trees and plants protect the surface from this waterproofing action of the raindrops. Their roots rot away, leaving the soil porous. Ants and other burrowing creatures create a maze of small passages that carry the water downward. Here it may spread many miles through the gravel and sand, forming a reservoir, which fills the soil to a level called the water table. From this great underground reservoir, the moisture is carried up again by capillary action to keep the soil moist above it. But plants require an unbelievable amount of water. It takes, for example, nearly 900 pounds of water to raise a single pound of dry alfalfa. And in many parts of the country, there is not enough rain to supply the crops through the dry summer. That is why the land must depend on nature's arteries to properly distribute the water stored up by the reservoirs of the mountain forests 10 miles or 1,000 miles away. This wild land may seem remote and useless to us, but our country could not live without it. Once upon a time, the beaver played a vital part in this distribution system. It has been estimated that there were 60 million beaver in this country when it was first settled. What a tremendous difference it must have made to the country's water supply when these capable dam builders were killed off. Now our own engineers must build huge and costly dams to store water. In desert country, water evaporates very quickly. The water lost by evaporation from this great Elephant Butte reservoir might irrigate many thousands of acres of land now wasted. And besides, silt washing off the eroding hillsides above is fast filling the reservoir. Many miles downstream, we find green, irrigated land, next to it, desert land, that might have been made productive if there had been sufficient water. The dam is certainly a poor and expensive substitute for natural storage. From these far-off snowfields, nature's own great reservoirs, the melting snow seeps into the ground to break forth into 1,000 springs. These flow out to join into brooks, and the brooks combine into rivers. Nature's arteries that keep the soil moist and bring life to the land 1,000 miles away. Here on the continental divide, near the mountain peaks, the water from the melting snow may flow east or west. A few pebbles may turn it west to flow 1,000 miles down the Colorado River to irrigate the farms of Southern California. Or turn it east to water the lands of the Mississippi Valley. Or south into the Rio Grande. We will follow it. Here in the fertile San Luis Valley, the irrigated crops depend on an even flow of this stored-up water. Without it, this land would be a desert. But irrigation canals carry it out among the farms, and ditches spread it over the fields. The water that is not used here flows on down the Rio Grande, and hundreds of miles below, it brings new life to the arid land in New Mexico and in Texas. Thus, from the mountain forest in Colorado, the arteries of life flow out to nourish the topsoil in California and Texas. And the soil in the great valley of the Mississippi depends, too, on this forest, and on the watersheds of the east, and on the condition of the topsoil in all the huge areas between. This raises the question, shall it be fertile farmland? Or shall it be desert dust bowl? Or shall it be buried under floods and filth? The answer lies with the man who uses the forest, the man who drains the marshland, and the man who tills the soil 1,000 miles away. Who shall have the right to decide how that land should be managed? Shall it be the individual owner, or shall it be the people of the nation, whose very lives depend upon the arteries of life?